Hey friends, and welcome back to my science studio. Today we'll be kicking off our nomenclature series, which is just a fancy way of saying how to name chemical compounds. You see, in this lesson, we will learn how to name covalent bonds, ionic bonds, and how to tell the difference between them. So, let's get to it. Okay, the very first question you should always ask when your teacher gives you a chemical formula is whether the bond is ionic or covalent. Remember, covalent is a sharing of valence electrons between two nonmetals, while an ionic bond is between a metal and a nonmetal. And metals, recall, they tend to donate their valence electrons, and nonmetals tend to accept those valence electrons. Now, rule number 1 in my nomenclature series is how to name binary covalent compounds, meaning two different nonmetals are present in this bond. And the rules say the first element keeps its original name. In other words, you do not modify it whatsoever. We can use prefixes to show the number of atoms as well. And there's a prefix list that you'll want to memorize. Mono means 1, di means 2, tri means 3, tetra is 4, penta is 5, hexa is 6, and so forth. A nice trick? Think of like your shapes. A triangle has 3 sides. A pentagon has 5 sides. An octagon has 8. You see, these shapes help you remember the number roots. And the prefix tells you the number of atoms that are present in a covalent bond. And lastly, for this rule, the second element, the other nonmetal, changes so that it ends in "ide." So for example, in this table, which these are the nonmetals from your periodic table, in group 4A, you'll notice that carbon is present. So carbon becomes carbide. 5A, if you take nitrogen, that becomes nitride. In 6A, oxygen becomes oxide. In 7A, fluorine becomes fluoride, and so forth. And it does take some time getting used to writing these names, but one thing I can recommend is using flashcards to help you remember the IDE endings and your prefixes. Now that we have a general understanding of these rules, we can go ahead and jump into some examples to put them into practice. Let's take the first one. P2O5. First identify, covalent or ionic? Well, phosphorus and oxygen are both nonmetals, so covalent. So we're going to be using rule number 1. We have 2 phosphoruses, right? So we're going to use the prefix di to show that there's 2 phosphoruses, hence diphosphorus. Again, the first element stays the same. The second element, oxygen, we're going to drop the ending so it becomes oxide. And then we'll use the prefix penta to show that there's 5 oxygens present. So let's put it together. Penta, oxide. But the problem is that we have to watch out for the vowel rule. You see, if your prefix ends in an A or an O, like in this example for penta, and the second element starts with an O or an A, in other words, it's oxygen or arsenic, you have to drop the last vowel of your prefix. So instead of it being pentaoxide, it'll just be pentoxide or pentoxide. So the full name we have diphosphorus pentoxide. Okay, let's try the next example. First identify, ionic or covalent? Well, carbon is a nonmetal and so is oxygen. So this is a covalent compound. So we'll be using rule number 1. Carbon, we don't change it. So we just leave it as is. But I have a question for you. There's only 1 carbon present. So do we use the word mono? The answer is actually no. You see, there's another exception where mono is never used for the first element. But we can use mono for the second. So for example, oxygen, we drop the ending so that it becomes oxide. Now we only have 1 O present. So my question for you is it monoxide or is it monoxide? You're right, it's monoxide. Again, If you have a prefix that ends in an O or an A, you have to drop it if the second element is an O or an A. So mono ends in an O and oxygen starts with an O, so we can't have two O's back to back like that. So we drop the O at the end of mono to get carbon monoxide. Now let's try the last one, which is a little easier. We have boron and hydrogen. So is this an ionic or a covalent bond? You're right, it's covalent. So the first element, boron, stays the same. But there's two borons present, so we're going to add the prefix di. What about hydrogen? Well, hydrogen, even though it's in group 1A of the periodic table, it's actually a nonmetal. So we're going to give it the IDE ending as we do with the rest of the nonmetals. And because there's 4 hydrogens present, we're going to give it the prefix tetra. So putting it all together, we get diboron tetrahydride. And so for the most part, this is how you name covalent compounds. Just keep in mind, number 1 and 2 has 2 common exceptions to the rule. The first is the dropping of the O or A at the end of the prefix if the second element starts in an O or an A, such as oxygen or arsenic. And the second exception is that the prefix mono is never used for the first element, but we can use mono for the second element if needed. Now, what if you have an ionic compound, meaning you have a metal and a nonmetal present? Well, now you're in Rule 2, and Rule 2 can be split into 2 parts, depending on the charge of the metal. Some books will tell you either name it as a type 1 or a type 2, but for me, and what makes sense in my brain is Rule 2A or Rule 2B. In other words, does the metal have a fixed charge or a variable charge? If you're on Rule 2A, that means that the metal has a fixed charge, meaning it never changes. That's what the word fixed means. It doesn't change. And for the most part, everything in this chart has a fixed charge. So for example, metals in group 1A will carry a +1 charge, which makes sense because metals in group 1A are more likely to donate their 1 valence electron to fulfill the octet rule and become a stable compound than they are to gain 7. In a similar way, metals in group 2A only have 2 valence electrons and are more likely to donate their 2 electrons to become a stable octet. And other specific ions that like to form a specific charge are, for example, silver or Ag likes to form a +1 charge. Zinc and cadmium also likes to form a +2 charge, and aluminum prefers to form a +3 charge. And so if you encounter an ionic compound where the metal has a fixed charge, it's actually quite simple to name because you see the name of the first element in the formula, or the metal, is not modified, so you don't change it. So it's similar to the first rule. And the name of the second element, the nonmetal, you change it so that the end ends in "ide." So also similar to rule number 1. So you're probably wondering, what's the difference then? Simple. You do not use prefixes. So your mono, your di, your tetra, all of those prefixes, you're going to throw it out the window for this next rule. So let's take the first example. NaBr. Identify, ionic or covalent? Sodium's a metal, bromine's a nonmetal, so it's ionic. So are we using Rule 1 or Rule 2? Rule 2. Is it Rule 2A or Rule 2B? Meaning, does the metal have a fixed or a variable charge? Well, sodium is in group 1A of the periodic table, and all metals in group 1A likes to form a +1 charge. So the metal has a fixed charge of +1, meaning we are going to use Rule 2A. And I promise you'll see in a minute why I tackle it in this way. Now the second element is bromine. So we drop the ending so it becomes bromide. And again, there's no prefixes used in Rule 2. So putting it together, we get sodium bromide. Let's try number 2. We have silver and phosphorus. Well, ionic or covalent? It's ionic. So we're going to be in Rule 2. Does the metal have a fixed or a variable charge? From the table, we know that silver will always be a +1 charge. So we'll be using Rule 2A. we name it. Silver for Ag, and phosphorus becomes phosphide. So putting it together, we have silver phosphide. Again, no prefixes. Number 3, CaCl2. Calcium's a metal, chlorine's a nonmetal, so it's ionic. So we're going to use rule 2. Does calcium have a fixed or a variable charge? Well, calcium is in group 2A of the periodic table and likes to have a fixed charge of +2. So it's a fixed charge. So we name it calcium chloride. We drop the second element's name from chlorine to chloride. And just as a little tip, teachers will always try to trick you with answers like calcium dichloride. But remember, prefixes are not used for ionic compounds. Now, if you encounter an ionic compound where the metal does not have a fixed charge, meaning it's not in this little table, now you're going to use the rules for rule 2b, where the metal has a variable charge. And as a little tip, transition metals usually have variable charges. So take this example, CuCl2. First identify, ionic or covalent? Well, copper is a metal, chlorine's a nonmetal, so we know this is ionic and we're going to use rule 2. But does copper, which is the metal, does it have a fixed or a variable charge? Well, it's not in the fixed charge table that I showed you earlier. It's actually a transition metal. And copper actually can be +1, +2. We don't know what the charge is. So we have to add a Roman numeral in order to denote the charge of the metal. And to find the metal's charge, what we can do is that we can uncross the subscripts. And if you haven't done so already, I highly recommend you check out my last video where I showed you guys how to cross the charges to create a binary ionic compound. But anyways, back to this problem. One thing I always tell my students is to always look at the nonmetal first. And I created a little chart here to show the most common ion formed for the nonmetals. And some of these actually make sense because if you remember from a previous lesson, chlorine is in group 7A, meaning it has 7 valence electrons. And because it's a nonmetal, it's more likely to gain 1 and form a -1 charge in order to form a stable octet and have a full valence shell of 8. So if we know that chlorine is a -1, that makes sense because this 1 as a subscript next to the copper, that tells you that it came from the chlorine. And again, when we cross charges, we don't cross the negative or the positive sign, we just cross the whole number attached to it. So what charge did copper have to be in order to create CuCl2? Exactly, a 2. This 2 next to the chlorine came from the copper. And metals tend to donate their valence electrons and form plus charges. So the magnitude of the copper is a +2 charge. And one thing you can do is that if you actually recross the charges and if you get the same thing that you started off with, then you're doing a great job. And so for this rule, you use the same naming rules as for 2A, but the only difference is that you add a Roman numeral next to the metal. So we have copper, Roman numeral 2, chloride. So copper 2 chloride. Now this next one's a little trickier. First identify if it's ionic or covalent. Well, nickel's a metal, oxygen's a nonmetal, so this is ionic. And nickel is not in that fixed charge table. So it has a variable charge. So we use rule 2b. In other words, we're going to be using a Roman numeral. Now remember that oxygen is always going to be -2. So if you uncross the subscripts, you'd incorrectly think that oxygen is -1 because there's an imaginary 1 next to the nickel. But that's impossible. Oxygen cannot possibly be -1. So this tells me that the chemical formula was simplified. So I ask you, what charge do you think nickel had to have been in order for us to get a simplified ratio of a 1 to 2? If you're thinking a +4, you're absolutely right. And let's check it out. When you cross a +4 and a -2 charge, you end up getting Ni2O4. But because we can divide the 2 and the 4 by 2, 2 divided by 2 is a 1, hence the 1 as a subscript. And remember, we don't write 1s as subscripts. Oxygen, 4 divided by 2 becomes a 2. So in the test, you'll probably see an answer choice that says nickel 2 oxide, which is wrong. Instead, the charge of the nickel was originally a +4. So we write this as nickel 4 oxide. So bottom line, you guys, always check if subscripts were simplified before figuring out the metal's charge. That could save you from getting into a trap answer. And that wraps up episode 1 of our nomenclature series. In our next lesson, we'll dive into how to name binary acids and bases, which, trust me, it's way easier than it sounds. Thank you guys so much for watching, and if you found this video helpful, please don't hesitate to like and subscribe and share to your friends. See you next time in my science studio, and until then, happy studying!